Welcome to the Math Show Skill Drills with Mr. DeClerico. Some things in life are perfectly certain. For example, if you get a box of French fries like this and find a random onion ring, you're going to have yourself a great day. But some things in life are almost perfectly certain. For example, if you find a 4-term polynomial in an algebra class, that can probably be factored by grouping, which is what this lesson is all about. Let's consider this 4-termed expression. Now, I'm going to argue that the best way to factor this is by dividing it up into 2 groups and factoring out the greatest common factor in each group. In my first group, the greatest common factor is 3x squared or negative 3x squared. But I'm going to factor out a negative 3x squared, and you'll see why in just a moment. In my second group, I'm going to factor out a 2. And you'll notice that I have a pair of x plus 4s. What's stopping me from factoring that out of my 2 factored groups? Well, nothing. That's exactly what I'm going to do. I factor out these x plus 4s, and what I have left are a 3x squared, well, negative 3x squared, and a 2. And so I have negative 3x squared plus 2 times x plus 4. That's my factorization, thanks to factor by grouping. Let's look at another slightly more challenging example. What makes this a little more challenging is that I'm going to need to do some housekeeping to get the groups that I want. Once you do a bunch of these sorts of problems, you'll figure out how to handle the housekeeping. Here are my 2 groups. Consider what you could factor out of each group. Pause the video and give it a try. All right, let's continue. In my first group, I can factor out a 5x squared. And my second group, I can factor out a 1? Is that legal? Well, of course it is. You just have the same thing inside that you had originally. That helps us with our factorization because I have a common 5x minus 1. I factor that out, and I'm left with 5x squared plus 1. Here's the 5x squared, and here's the 1. Now here's one for you to try all on your own. Feel free to pause the video and try to factor this. You'll need to do a little housekeeping and rearranging before you begin. All right, let's try this one. I'm going to rearrange like this. Use a little commutative property. Now I'm going to factor out a negative 2x squared from my first group on the left and a 1 from my second group on the right. Factoring out the x plus 7s, I have negative 2x squared plus 1, and that's my factorization. Now let's look at this 3-termed expression right here. In the last video, we factored trinomials, but not like this one. You will quickly notice that the leading coefficient is not 1. That makes this a tougher factorization. But this does factor, in the integers no less, and it'll factor using factor by grouping. Let's begin. We are now looking for 2 numbers that fit a different description than in my first factoring video. They need to multiply to 2 times 9 equals 18. Now, where do the 2 and the 9 come from? Well, check this out. The 2 is my leading coefficient, and the 9 is the constant. Before, we were looking for 2 numbers that multiplied to the constant. But now they need to multiply to the leading coefficient times the constant. They also need to add to negative 9, which is, of course, the coefficient of x. Those numbers would be -3 and -6. Now watch what I do with this -3 and -6. I split the x term into -3x and -6x. Notice my middle term would still equal -9x. I just represented it differently. And this is a good difference because check out what I can do. I now have two groups. My first two terms and my last two terms. Those sets of terms are going to be the groups from which I can factor. I factor an x out of the first two terms and a -3 out of my second two terms. Conveniently, I have a 2x minus 3 left over from each pair, which I can factor out. Now this is really neat that it works, but if you're like Mr. Penguin, you want to know why. And just like last time Mr. Penguin asked a question, this is a nerd alert. I'm going to explain why this new method of factorization works, but this is for nerds only. If you're not a nerd like me, or some of you watching, feel free to advance to the practical applications. In order to understand how this new method of factorization works, we're going to actually just start with the factorization itself. ax plus b times cx plus d, where a, b, c, and d are just placeholders for numbers, is the generalized form of the factorization we've gotten in this entire video. If I were to FOIL these two binomials, I would get this mess. But I'm going to embrace the mess, and I'm going to factor out an x from the middle two terms. And though this may look like an even bigger mess, I notice that AD and BC, the coefficient of x, would constitute two numbers. Those two numbers, AD and BC, do in fact add to the coefficient of x, and they multiply to the coefficient of x squared and the constant. If you multiply AD and BC together, you get AC times BD, since multiplication is commutative. That's how we split our middle term to make it factor. Let's try out our new factorization technique. Here is a three-termed expression that will factor. We want two numbers that multiply to the coefficient of x squared and the constant, which is 12, and that add to the coefficient of x, which is 7. Those two numbers are 3 and 4, so we split 7x into 3x plus 4x. Notice I haven't changed my x term, I've just represented it differently. Now I think about how I would factor by grouping. I have my two groups, the -3x squared and the 3x, and my second group, the 4x minus 4. Factoring the greatest common factor out of both, I see I have a common x minus 1. I'll factor that out too, and that's the answer. Now here are some for you to try on your own. Give these a go, pause the video, and see how you did. All right, I'll assume we're ready to continue. Here's the answer to number 1, as well as the first step. And here's the answer to number 2, as well as its first step. Notice how I split the -6x into -10x plus 4x. Thanks for watching this video. And if you're feeling what Mr. Penguin is feeling, check out my website in the description. And as always, be sure to click subscribe, hit the like button, and all that good stuff.